Okay, I started off this presentation by going through, I was going to show you some of the craters that I've explored that are actually underwater. And in my research, I found that I've exposed a monster. There's so many things to learn about craters that I had to stop my research and just stop. Actually, about 4 o'clock this afternoon is when I did my last notes here. So next slide, please. Okay, so I'm going to start off by one underwater crater I bet you've never heard of, Montaigne. Did I pronounce it right? Next slide. There it is. It's right off the coast of Nova Scotia. I wanted to show it because I have it on my website anyway. It happened 50 million years ago. Most of the modern mammals were just starting to appear. Many bird orders appeared, and reptile fossils were very abundant at this time, 50 million years ago. And next one. Next one. Right there. That's about when it happened. And the next one. Okay, this is how far it is off the Nova Scotia coast, and that's about the scale of it right there. This is a gravity anomaly map, and this is how they discovered it in the first place. It's 11 kilometers wide, and it's in 115 meters of water, so obviously I couldn't see it from my airplane. It is filled with shock deformation features, and that's how they actually identified it with a drill. Next one. And they did drill, and I want you to note that there's actually 3 stages here. One, the sediments, I'm going to refer to that in a bit. The melt zone, this is where they actually could date the crater, identify the impact melts and so on, and finally right down to the bedrock. So yes, it is a definite crater, and it did, we don't know how much of the evolution of the continent it had an effect on. And this is what I was starting to investigate. Next slide. But I got as close to it as I could from my airplane. This is Shag Bay, just in the south coast of Nova Scotia. And where the arrows are, right through the fog there, that's about where the crater is, about 200 kilometers off the coast. And there was no way I was going to fly out there to take a picture, so I stayed where I was. But as I mentioned, I was looking for some kind of effect that this crater might have had in Nova Scotia. And I got involved with the ejecta, and it's basically, I wanted to find out what effects the craters had and what signals they've left for us to find. And essentially what I've seen is distal ejecta layers. Now, we all know about the KT layer. Next slide, please. When the old dinosaurs made their Waterloo, and there's our little ancestor running for his life. This was 65 million years ago, and one of the major distal ejecta layers called the KT layer. This was found in the 1980s before we even knew why the dinosaurs disappeared. Next one. And next one, right there, 65 million years ago. So it was about 10 million years ago before the Montaigne crater, and 10 million years is about the time where humanoids evolved from the first little mammals you saw there to what we're doing now. And next one. So I'm talking about distal ejecta layers. This is the KT boundary, the Cretaceous Tertiary boundary that was discovered worldwide because of the Chicxulub impact crater. Now these layers, there's actually many of them I found. There's the KT, of course. Sudbury has a ejecta layer around. Manicouagan, there's an ejecta layer over in Scotland. Some of the craters in Europe actually have ejecta layers. And it was from this distal ejecta layer, like this, where they, actually Dr. Hildebrand, part of the RISC, was a very major contributor to this, was actually used these layers to research exactly where the crater is. Next one, please. And it's right on the Yucatan Peninsula. You can just barely see it. I don't have the laser. We don't have a laser, do we? Oh, we do, by golly. Anyway, you can see the kind of the circle in the. I have one here. Yeah, do you have one? Hey, Brian, to the right. I got it. It's silver. Silver button? Thanks very much. Yeah, you can see the shape of it here. And it was funny that They knew that shape a long time ago before they even realized it was a crater. These are the cenotes. They're the little holes in the ground from the sedimentary rocks that rain had sort of eroded through and left a bunch of holes. And they tended to be in a circle like this. And it was one of these things that's sitting there right in front of you, but we didn't really know it was a crater. Well, Dr. Hildebrand, from this distal ejecta layer, calculated where the crater should be, and lo and behold, yes, there was a crater here. And even before Dr. Hildebrand found it, oil companies had actually drilled off here, looking for oil, of course, and they actually drilled through a breccia layer similar to the Montana one I just showed you there. And from that, they extrapolated to say, yes, this is probably the killer asteroid crater from the dinosaurs. And from there, of course, it's history. There's been hundreds of thousands of papers written on it now, which shows that, yes, this is probably, most definitely, 99% chance of the demise of the dinosaurs. Next one, please. So, what we're looking at here is a distal ejecta layer that happened 12,500 years ago. And it's right where we're standing right now. It, just give me a second here. We found this layer is similar to the KT layer. It has the similar properties, iridium, glass spherules, and a new thing that we've just started to research, and we had a talk about this just a little while ago, nanodiamonds. Al Scott gave a presentation on this. And nanodiamonds are kind of unique. I'll get into it in a second. Next slide, please. So this 12,500 years ago, this is called now the Younger Drya. So it was right at the point where this black mat, or the distal layer, has been discovered. And it preceded what is called the Younger Dryas. And right at this point, lots of things disappeared. This woolly mammoth, for one thing. The Clovis people, the Clovis were a race of people who had the most advanced technology on the planet at the time. And they disappeared. So before this time, mammoths existed. After this time, nothing happened. Why the temperature went down, I'll explain in just a little while. It's kind of neat. Next one, please. So what happened is a lot of large animals just disappeared. All this was there, and then poof, within an instant of geological time, disappeared. Why is the problem? So, next slide, please. What we have is a distal ejecta layer across North America. Now, this is another one, totally independent, probably a talk of another, a subject of another talk. It's a distal ejecta layer in the Australasian field. And again, there's absolutely no crater to identify for that field, and it's full of tektites. Ron has a few. I have a tektite from that area. It's definitely an impact, but there's no crater. Same here. We've got the distal ejecta layers found in Europe and all the way through North America. And what I'm going to do is show you exactly what's in there. Next one, please. Oh, that was Greenland as well. There's one in Greenland. So there's a collection of the distal ejecta layers that we found across North America. And all at the same time, something happened. You can actually see it there. Something actually happened. What, we really don't know yet, but I'm going to show you some evidence that we think we know. But what we know for fact is that the woolly mammoths lived there. They didn't live here. The Clovis population, the highest technology that we had, lived here 12,995 years ago. Now, 12,900 years ago, they didn't. That's a fact. Within these layers, I'm going to read them here. There's magnetic grains with iridium, magnetic microspherules, charcoal, soot, carbon spherules, and glass-like carbon-containing nanodiamonds. Now, all of those are indications of a impact, and I'm just going to concentrate on the nanodiamonds tonight. But just to point out, there was a sudden disappearance of the first Stone Age people in North America right at that point. 35 mammals, 19 bird genera became extinct. And the sudden cooling of the planet lasting 1,300 years happened right at that point. So something big happened. What is the question? Next one, please. Okay, this is an example of this distal ejecta layer. It's called the black mat. This is the one in Arizona. I mentioned the Clovis people with their technology. This kind of Stone Age technology was only here on this planet. Apparently there was a couple places in Europe, they think, but North America at this period of time had the highest technology. Now just trying to extrapolate here, if that population wasn't extinct at that point, we might be at the stars right now. But they went poof. Anyway, so that mat, as I said, the mammoths were there, they're not there. And there was no indication of any humanoid environments until later up in that layer, maybe 11,000, 10,000 years ago. Next one, please. So, what the geography looked like, we had the Ice Age. There's a big ice cap here. This black mat was down here, the picture we just showed you. All these points here had all those materials I explained to you, plus the nanodiamonds. And I just want to point out, right in here was a large lake. It's not shown in this diagram. It's called Lake Agassiz. And it was melt, like the glacial parts were here, and there's a giant lake here, probably the volume of the Great Lakes plus. And that's going to be significant in just a little while. I just wanted to point that out. And next one, please. So here we are at this black mat. This is in Arizona. There's no in situ Clovis points and extinct the megafaunal, those woolly mammoths. There has nothing been found at the mat or above it. But below the mat, there's lots of those fossils, plenty of them. This indicates that the mammals and Clovis hunting technology disappeared simultaneously. Basically, those extinct animals plus the Clovis population disappeared. Next one. And looking inside the mat, we've got, these are glass-like carbon lumps, carbon spherules here, and magnetic grains rich in iridium, these ones here. And iridium from the KT boundary was a definite indicator of an impact. Iridium is an element that is common in meteorites, comets, but is not common on the Earth because it's a very heavy element. And when the Earth was molten, of course, the heavy element sank to the core. Whereas if you find iridium at a layer, the KT proved the fact, yes, it is an impact that caused this iridium spike at that point. Next one, please. So, and again, an example of the Clovis point. These magnetic spherules, they are significant, and you'll see an excellent picture of why in a few minutes. So no human artifacts, including a lack of occupation for many years after that mat. So there's no occupation at all up here from humans. Next one. Now this is in Manitoba, and we have an iridium spike here. And this indicates that it might be close to the impact site. Iridium is extremely sparse on the Earth, but is abundant in meteorites and comets. I mentioned the lake right beside the glacier just a little while ago. It's called Lake Agassiz. I think I pronounced it right. The hypothesis is that if there was an impact on the ice sheet, that broke loose that lake, caused it to flow into Hudson Bay, through the Hudson Strait into the Atlantic Ocean, of course, cooling the ocean substantially, causing this Younger Dryas cooling period for the next 1,000 years. That's a hypothesis, but it's a possibility, I suppose, with that impact. Next one, please. Okay, so I got into nanodiamonds. In 2008, we're getting pretty close to today, a discovery in nanodiamond-rich layer in the Greenland ice sheet. This is the first highly enriched discrete layer of nanodiamonds observed in a glacial ice anywhere. The diamonds were found embedded in metal alloy cosmic grains, and they were not free in the ice, so they're embedded within the grains here. Next one. So this is the spike of nanodiamonds. Now, nanodiamonds are common in meteorites. So what you have the noise from, there's meteorites landing on the planet all the time. So you're going to get the noise level of nanodiamonds found along any line. But all of a sudden you get a spike. So something big must have happened. And the chances are it's from an impact from a bolide of some type. So it is probably close to the impact site. And another point is that at this point, as an aside, the Niagara Falls Gorge started at this time as well. It's not a connection to my talk, but I just wanted to mention it as a trivial piece of information. It'll be on the exam. Next slide. So now we're coming up to a very close piece of research. This is a paper dated March the 5th, 2012, just last month. This is a lake in Mexico. Nanodiamonds called lonsdaleite. They're also called hexagonal diamonds, and there's one professor actually called them detonation diamonds. They were conclusively identified in this lake, Lake Cuzio in central Mexico. A 27-meter-long core sample drilled from this lake contained a 10-centimeter thick carbon-rich layer containing the nanodiamonds. The nanodiamonds were 20 to 1,800 nanometers in diameter. That's pretty small. This carbon-rich layer is consistent with the Younger Dryas boundary layer found at numerous sites across North America, Greenland, and Western Europe. The researchers also found spherules that had collided at high velocities with other spherules during the chaos of the impact. Again, this is another definite indicator of a cosmic velocity collision. Next one, please. So we're getting into some technicalities here. In another life, a long time ago, I was in semiconductor failure analysis, and I used scanning electron microscopes just about every day. And this is technology used from a scanning electron microscope. First of all, it's a transmission electron microscope, which what it does, it sends a very high energy electron beam through a very thin sample. And what we get are called selected area diffraction patterns. And these patterns will identify the crystal lattice of lattice of these diamonds. And doing this research, I've learned a whole bunch of stuff. And another big word I learned is called allotrope. I never heard of it until I did this research. But what it is, it's the ability of an element to exist in two or more different forms. Very important. Now we're getting into nanodiamonds here. These are definitely identified as nanodiamonds. These diffraction patterns define the crystal lattice of the diamond itself. So what does this have to do with impact? Okay, next slide, please. This is from the Mexican site, and this diamond here is definitely identified as a lonsdaleite. It is a hexagonal diamond, a detonation diamond, and it is a allotrope of nanodiamonds. It is definitely, absolutely, the result of a cosmic impact. The only thing that would have as much energy as this is probably a nuclear explosion or a cosmic velocity impact with our planet. So this is almost the smoking gun, the same smoking gun as the iridium in the KT layer. So, in nature, it forms when meteorites containing graphite strike the Earth. The great heat and stress of the impact transforms the graphite into diamond, but retains the graphite's hexagonal crystal lattice. In other words, from an impact, this is the crystal pattern you get, and it's only from the energy from an impact. This element, lansdellite, was first identified in 1967 from the Canyon Diablo meteorite. That's the meteorite crater in Arizona, where it occurs as microscopic crystals associated with diamond. They are also found at Chicxulub, Kara, Ukraine, Rays, and the Sudbury craters. So these are definitely associated with impacts. Next one, please. Now, this is my personal sample of the Tagish Lake meteorite, the one that impacted here a while ago. Originally was a 56 metric ton meteorite that rained down over a wide area of Canada in January 18th, 2000. And I mentioned earlier that nanodiamonds are 99% found in meteorites. They're not a natural part of our planet. They're found in meteorites. Next one. So, doing a little bit of research in my home lab. It's the carbonaceous. The Tagish Lake is a carbonaceous chondrite. It's a type of meteorite. It has a nanodiamond abundance of about 4,000 parts per million, and this just happens to be the most populated meteorite with nanodiamonds found so far. They're contained within the carbon within the meteorite. Now, I'm looking at, see this guy here, that's about 2 microns across. So a nanodiamond I quoted was up to 18 nanometers, which is over a micron, 1.8 microns, down to less than your visible sight. So these are either nanodiamonds or carbon containing a nanodiamond. It was fascinating exploring this meteorite. I just love it. That's okay. I was going to that one anyway. And as I mentioned earlier, the spherules were found in the Younger Drya layer at Lake Cuzo in Mexico. These spherules collide and fused, which happens only during a cosmic velocity impact. So the evidence is there. And remember, it was the investigation of the KT layer that allowed us to find where the KT impact crater was. This was actually Dr. Hildebrand was prime on that. So, the highest, next one please. The highest concentrations of the extraterrestrial materials that we found occur in the Great Lakes area, up in here somewhere. And basically it gets less and less from there. Some are found in Europe and some in Greenland, but the concentration seems to be around here. Next one, please. So I've documented empirical evidence for an impact somewhere in or over North America that coincided with extraordinary biotic and environmental changes here in the last 20,000 years. Basically, something big happened 12,900 years ago. The implication is, yes, it's an impact. Where is the crater? Well, I'm getting into my personal opinions now. This is my hypothesis. English is not my forte. The plural of hypothesis.
Hypotheses.
Hypotheses?
Yep.
It's not hypothesi. Okay. Okay, next one, please. Hypothesis number 1. Now, we all remember Comet Shoemaker hitting Jupiter. So we know that comets do disintegrate. Comet just recently disintegrated close to us as well. I can't remember the name of it. Next one, please. So, 12,500 years ago, my thoughts, that one that hit Jupiter was a factor of 19 times the energy that hit Tunguska. I figure this might have happened 12,500 years ago. Fragments and debris from a large comet hit our atmosphere, producing a large aerial burst, or bursts. So Tunguska, next one, was about 5 to 30 megatons. The event is consistent with a stony impactor 30 to 40 meters in diameter, exploding 6 to 10 kilometers above the planet in the atmosphere. So could the Younger Dryas event be a multiple explosion? The cause be a multiple explosion of this type? Well, that's one of my thoughts. Okay, next one. Hypothesis number 2. Could it have happened on the ice sheet? Again, this is Lake Agassiz here. Apparently, it did drain into the Hudson Bay and out, which caused the Atlantic Ocean to cool substantially, which caused the 1,000-year cooling period. So getting back to it here, my hypothesis again, an 8-kilometer wide bolide had broken up in the atmosphere and that most of it had hit the Laurentian ice sheet. Okay, so what, I say. Okay, next one, please. If you've been a fan of the Discovery Channel and Naked Science, Dr. Schultz here has been a star for a while with his big cannon. He impacts stuff and shows what gets close to a cosmic impact speed. 12 kilometers a second is the escape velocity of our planet. So a bolide with the minimum velocity would be 12 kilometers. I think the gun that he uses gets close 12, 13 kilometers a second. That's about it. But even so, he's done a lot of research. And what you're looking at here is an impact flash at the NASA Ames hypervelocity vertical gun range. He simulated a low-angle hypervelocity impact into ice. And his results, as he calculates that a 1-kilometer wide bolide coming in at an oblique angle can hit a 1-kilometer thick ice sheet and leave no crater. And he would need, of course, there'd be a crater on the ice, but what he meant is that there'd be no crater on the surface under the ice. The impact would leave a randomized pattern on the surface after melting. 90% of the impactor's mass may be vaporized upon impact. Next one, please. Hexagonal diamonds formed in the temperature-pressure combination of this impact. That's my hypothesis for that one. So hypothesis number 3 is a multiple impact. And I want you to go ahead 5 times. 1, 2, 3, 4, 5. This is my final personal hypothesis. Okay, next one, please. First one might be, next one, Charity Shoal. It's just south of here in Lake Ontario. Next one. I've superimposed a circle. This is my aeronautical chart. It's right about there. Kingston's here. Charity Shoal is about there. It's 1 kilometer wide. And what's interesting is right in here is an indicator for pilots that there's an extreme magnetic anomaly. Basically, the compass goes wonky if you fly in this area. So don't rely on your magnetic compass, which implies maybe a iron object landing there. Could it be a cosmic velocity iron object? I don't know.
Have the people navigating on with a boat reported the same thing?
Oh yeah, yeah. You would find your deviation would vary by 5-10 degrees maybe. Next one. This is an example of Charity Shoal underwater, 1 kilometer across. That's the width here. We cannot identify that as an impact for sure. We haven't dated it, but it is one of the possibilities for an impact causing the Younger Dryas. Next one. This is a picture I took from my airplane over the shoal on a calm day, and that's the best I could. It's under about 40 feet of water. So that's crystal clear Lake Ontario, not bad. Next one, please. So the next one is one in Nova Scotia called Bloody Creek. It is a crater 1/2 kilometer in diameter. It's 10 meters deep, and it's just been found, and planar deformation features have been found in the area. Planar deformation features is shocked quartz, which again is a definite impact, indicator of an impact. Next slide, please. Okay, this is a movie. Let it roll. See if it works.
Hidden underwater in Nova Scotia's Annapolis Valley could be the answer to one of the great riddles of Earth history. What wiped out North American wildlife? Saber-toothed tigers, mastodons, woolly mammoths were gone in an instant. Now, as Daryl McIntyre discovered, a Canadian scientist is on the hunt to find out what happened so long ago.
It may not look like much from the air, but to scientists who know better, Nova Scotia's Bloody Creek Hydro Reservoir holds a discovery that's got researchers around the world buzzing.
It's mostly underwater right now. Some of those small islands sticking up form the rim of the crater.
Hidden just below the surface is a crater nearly half a kilometer long. Aerial photos taken before the land was flooded show it clearly. A rare oval-shaped crater formed by a low-entry meteor.
The meteor, when it came in and struck, had to be coming over the horizon at 15 degrees or less. So streaking across the trees, it would have been, something incredible to see.
Dr. Ian Spooner has studied the crater for 2 years.
It would have been the last thing, probably anything in at least a 500, maybe even 1,000-kilometer radius would have seen. The destruction would have been total.
Early clues suggest this may have just happened, in geological terms, about 12,000 years ago. And that's got the attention of scientists of all kinds, including one who thinks this site may finally answer an archaeological riddle. What caused the mass extinction of saber-toothed tigers, mastodons, humans, almost all large animals in North America at the end of the last ice age?
These animals were major players in the landscape of North America up until exactly, we suggest, 12.9 thousand years ago, and then they were gone. Gone in an instant.
Dr. James Kennett thinks a meteor strike is to blame, and Bloody Creek could prove it.
This may be representing a smoking gun, if you like.
Ultimately, the answers lie in core samples taken from lakes around the crater. Using layers of sediment to count back through the centuries to that global cold period, Ian Spooner is now searching for signs of a cosmic element that would have blanketed the area at impact.
So if we saw an iridium spike in this core, then, especially if it was right here, right at that point, and that's right before this Younger Drya school interval, then there'd be something that would be a very provocative result. We look out into the distance here.
In fact, Spooner says it would force scientists everywhere to rethink their understanding of one of the biggest global catastrophes ever. Daryl McIntyre, CBC News, near Dalhousie, Nova Scotia.
Anyway, essentially what happens, these are scientists that have investigated the crater. It's under a swamp right now, but as I mentioned, they did find planar deformation features. It is associated with the Younger Dryas extinction. The dating of this crater is very close to the Younger Dryas initiation. And you can see the size of the crater here. And this is scientists talking scientific stuff. Yes, it is a crater. Yep, it definitely is a crater. Yep. Chuck O'Dale will look at it. Yep, there we go. But anyway, it's if anybody wants it, I have it on my computer. I can email it to you. It's a short little clip from the CBC. And actually, the Nova Scotia RASC was involved in it for a while, a few years ago. Unfortunately, now they put a dam on that little creek. And this is a doctor, I can't remember his name now, but he was the first one to identify the nanodiamonds in the Greenland ice sheet that I showed you earlier. And these are the extinctions that they're talking about. Right at the 12,000, poof, all these guys were gone. It was, Kennett. Again, he was on the Science Channel, The Naked Science, and he was on the NOVA, actually. The NOVA one I quoted earlier, he was the guy that discovered the hexagonal diamonds within the carbon spherules within the Greenland ice sheet. Anyway, just jump ahead. Okay, that's a picture of it before they put the dam on, and it's fairly substantial. Half a kilometer, half the size of the Charity Shoal, but still substantial. It would have been one heck of a hit, and it would have the fireball probably would have gone as far as Quebec City. So it gives you an example of the energy that you're looking at here. Okay, next slide, please, and the next one. There's a brand new one that I just read a paper about, published just last year. Next one called Corosol Crater. It's just south of Sept-Îles, and it's right in there. Again, it isn't 99% identified as a crater. They haven't got any in situ rocks from the site, so they can't say that definitely it is a crater, but they did find impact breccia with a planar deformation feature within the site. Not in situ, but very, very suggestive. Next one, please. So that's a close-up of it. It's 4 kilometers in diameter. So 1 kilometer for Charity Shoal, a half one for the one in Nova Scotia, and 4 kilometers here. So they're pretty big. And again, the fireball would probably go across half the country on this one. It's rise about 70 meters, the central peak. And the valleys here is 160 meters deep. The carbon-14 ages of the shells and the sediments can be extrapolated to give an estimate age of 12,900. It won't be younger than that. It could be older. Now, this is taken to the youngest possible age. It's the largest known crater in North and South America within the last 35 million years. So this happened just recently. Pretty cool. And next one. So up north, Eric and I flew over a little site called Merriweather. Again, next one. This could have been part of this as well. This is the fourth one of my hypothesi. There are actually 4 sites here. This is the big one. This is about 100 meters across. 1, 2, 3, 4. If Eric and I ever get there, we're going to do some science because this one and this one have been sounded. They know the profile of the lakes, but these 2 haven't. So if we ever get there, we'll do some science, Eric. And finally, next one, please. There is a series of lakes up in northern Quebec. It could have been a swarm of craters. I don't know. You're looking at, over a kilometer across, and each one is about a kilometer. So again, if you're looking at impacts here, these fireballs would have been substantial. So these are my hypotheses for the impacts that we know that happened. Next one, please. So we've got the 5 impact sites. Lake Agassiz, again, when the ice failed, we got that large disruption, this large drainage of the fresh cold water into the Atlantic Ocean, which caused the Younger Dryas and the extinction. Next one, please. So, here we are. What you're looking at here is the Hale-Bopp crater. Remember I mentioned the Chicxulub crater that caused the dinosaurs to go was 10 kilometers across. Hale-Bopp here is 60 kilometers. Now, if the Younger Dryas event was due to an encounter with a swarm of debris 12,900 years ago, the material would still be visible in the inner solar system. So, as I mentioned, this is a monster I've created. There is a paper by a guy named Dr. Napier, and he hypothesized that the extinctions are from a Truid complex of craters, of comets. And he gives several hypotheses of periodic comets and debris that may be the culprit. Now, this is a subject of a possible future talk, but we have maybe where the craters are and maybe what the comets were. Like, of course, we all know the meteor storms that we go through are comet tails. And if the comet and the Earth happen to occupy the same space at the same time, we know what happens. So, as I mentioned, Hale-Bopp here was 60 kilometers across. And I like to quote Isaac Asimov here. How bright and beautiful a comet is as it flies past our planet. Next one. Provided it does fly past it. Thanks very much. Hey, rock and roll. And Brian, this is yours.